Satellite technology. A satellite is a microwave repeater station that permits two or more users to deliver or exchange information simultaneously. Primary role of a satellite is to reflect electronic signals. It receives the signals from a ground station and sends them down to another ground station located at some other part. Communication satellite is divided into two parts. One, the space segment, and the second one is ground segment. A space segment is composed of three units: the fuel system, the satellite and telemetry controls, and the transponders. A satellite consists of certain subsystems which allow the spacecraft to provide a stable platform and can be capable of station keeping. For example, the purpose of altitude and orbit control system is to decide the satellite orientation in space. As this orientation is subjected to drift due to various reasons like gravitation force from sun, moon, planet, electromagnetic fields and atmospheric pressures, so in order to prevent any drift, this subsystem is used in satellite to move the satellite back to its orbits. Telemetry, tracking, control and monitoring is used to monitor the performance of all the satellite subsystems and transmit this monitored data to the satellite control centers. These subsystems can be on the satellite or on the earth. For power system, solar panels are used, which convert incident sunlight into electrical energy. For secondary backup, nickel-cadmium storage batteries are used. Communication subsystems consist of a set of transponders that receives the uplink signal and retransmit them to Earth. Transponders are derived from transmitter and responders. It receives signal from Earth station, amplifies it, processes it, and then retransmit the signal back to the ground station. The antennas which are most widely used in spacecrafts are wide antenna, reflector antenna, horn antenna, and array antenna. The Earth station has two main functions. For uplink system or transmitting station, the terrestrial data in the form of baseband signal is passed through a modulator, an up converter, and a high power amplifier, then passed through an antenna to orbiting satellite. The downlink or receiving station works in reverse fashion as the uplink, finally converting signals received from the antenna to baseband signal. The frequency band used for satellite is in C band and Ku band. The altitude at which satellites are placed are decided by using Kepler's law. Kepler's first law states that orbit of each planet follows on elliptical path in space with Earth as a focus. Kepler's third law states that the square of planet's orbital time period around the Sun is proportional to the cube of mean distance between the two bodies. Based on the altitude of satellite is classified as lower Earth orbit satellite, medium Earth orbit satellite, and geosynchronous Earth orbit. Lower Earth orbit satellites are mainly used in remote sensing and providing mobile communication. In medium Earth orbit, satellites are used for GPS and navigation. In geosynchronous orbit, satellites are mainly used for global communications like TV and radio communications and for military applications. The main advantage of satellite communication is the quality of signal regeneration is independent of distance. Other advantages are the satellite costs are distance insensitive and they can cover large areas. The disadvantages of satellite communications are the initial costs are very high. They require a very high precision to keep the satellite into an orbit, and they have a short lifetime of 7 to 10 years. For more detail, visit our website easyelectronics.co.in.